Hi, and welcome to the course Dependency Injection, a C# Developer's Guide to DI Patterns. I'm Ganesh, and I'll be your instructor for this course. Dependency injection is an essential skill for creating maintainable software, especially for larger and more complex applications. Modern frameworks like .NET, Angular, and Spring for Java rely heavily on dependency injection for dependency management. So learning DI allows us to use these frameworks effectively and take advantage of their core features. In this course, we start with the foundation, where we first define what dependency injection is, then take a look at dependencies, how the dependency inversion principle is violated, which leads to tight coupling, and how we can make our code loosely coupled by applying the dependency inversion principle. Next, we'll talk about the various dependency injection design patterns such as constructor injection, method injection, property injection, and composition root. And by the end of this section, you will have learned the first dimension of dependency injection, which is object composition. In the next section, we talk about the other two dimensions of dependency injection, which are lifetime management and interception. Here, we discuss the various service lifetimes such as singleton, scoped, and transient. Finally, we talk about the .NET dependency injection container itself, where we look at the basics first, then the different ways of registering services, how to register groups of services with extension methods, and more. So, by the end of this course, you will have a solid understanding of the basics of dependency injection in .NET. As for the target audience, this course is suitable for entry-level C# developers who know the basics of object-oriented programming and want to learn what dependency injection is and how it works. That said, experienced C# developers who want to take their skills to the next level by mastering the basics of dependency injection can also benefit from this course. So thank you, and I hope to see you on the other side. For this course, I'm using .NET 9 SDK, which you can download by going to this URL here. And I'm using Visual Studio 2022, which you can download via this URL here. While installing Visual Studio, make sure the ASP.NET and Web Development workload is checked, and under Individual Components, make sure SQL Server Express 2019 Local DB is checked as well. In this video, we will define dependency injection. Dependency injection is a set of software design patterns that is used to implement a principle called the Dependency Inversion Principle. This principle is one of the 5 solid principles of object-oriented design, and the principle in turn enables loose coupling between classes. Or we can say, dependency injection is a way to provide or inject an instance of a dependency that an object needs, rather than having the object create an instance of its dependency itself. Now don't worry if these definitions don't make sense at this point. They will all become clear by the end of this course. In the next video, we will see what a dependency is. In this video, we're going to talk about dependencies. What is a dependency? A dependency is simply a class or an object that another class or object depends upon. Let's see an example. Let's say we are building a simple book catalog application using a typical 3-layered architecture. So we will have a presentation layer which contains a form for the user to enter book information, a business logic layer which contains a class called book service that contains business logic, and finally a data access layer which contains a class called book repository to hold data access logic using entity framework core. Let's focus on the business logic and data access logic layers and not worry about the presentation layer for now. The book repository class contains a method called addBookAsync that book service wants to invoke. So a book service object depends on a book repository object for its functionality. So we can say the book repository object is a runtime dependency. But just because a book service object depends on a book repository object at runtime, it doesn't mean that the book service class itself should create an object of book repository. But if that happens, then the book repository class will be a compile time dependency as well. Let's see some sample code to understand this better. I have opened up a Visual Studio solution with two class library projects in it, one for the business logic layer and another for the data access layer. In the business logic layer project, I have a class called book service, and in the data access layer project, I have a class called book repository. If we go to the book service class, we see it creates an object of book repository in its constructor. And down here, it calls its addBookAsync method. So just because a book service object needs to use a book repository object's addBookAsync method, the book service class ends up creating an object of book repository. So now the book repository class is a compile time dependency as well. So with this we can say that the direction of our runtime dependency matches the direction of our compile time dependency, which is from book service to book repository. In the next video, we will take a look at the dependency inversion principle and see specifically how our code violates the principle. In this video, we're going to talk about the dependency inversion principle and see specifically how the principle is violated in our code. The dependency inversion principle states that compile time dependencies should not flow in the same direction as runtime dependencies, or high-level modules should not depend upon low-level modules. Both should depend upon abstractions. In the previous video, we saw that the book service class had a compile time dependency on the book repository class, and that the direction of our compile time dependency is the same as our runtime dependency, from book service to book repository. So according to the first definition of our dependency inversion principle, we can already see the principle is being violated in our code. Also, since the book repository class belongs to the data access layer project and the book service class belongs to the business logic layer project, and book service depends on book repository, the business logic layer project, which is our high-level module, contains a project reference to the data access layer project, which is our low-level module. So according to the second definition of the dependency inversion principle, which is high-level modules should not depend upon low-level modules, we can see once again our code violates the principle. Now a violation of the dependency inversion principle indicates that our code is tightly coupled. That is, the book service class is tightly coupled to the book repository class. In the next video, we'll take a look at tight coupling and its issues. In this video, we're going to take a look at tight coupling and its issues. The main problem with our sample code is that the book service class is heavily dependent on the book repository class, or we say the book service class is tightly coupled to the book repository class. Now tight coupling has several issues. One is that it makes the code hard to maintain. The book repository class currently uses Entity Framework Core as its object relational mapper. Now let's say we want to switch to Dapper. Then we can go ahead and create a new class called Dapper Book Repository that contains Dapper specific logic, but then we have to modify the book service class to refer to the new Dapper Book Repository class. Here we need just a single modification because there is only a single reference to the book repository class. But imagine we had several different classes that refer to book repository, then we have to modify in multiple locations, making the codebase harder to maintain. Another issue is that it makes it hard to unit test our book service class. To test our book service class, we need an actual instance of book repository, which in turn sets up the Entity Framework Core ORM to talk to the database. So we cannot replace our book repository dependency with test-specific alternatives, making it difficult to isolate our book service class for testing. Next, our current approach emphasizes a data-driven design. The book service class creates an instance of book repository. So this means that the book repository class needs to be written before the book service class is written. This in turn implies that the data access layer, which contains the book repository class, needs to be written before the business logic layer is written. But in any real application, we should be able to start from the core of our application, which is the business logic layer, and then later implement our data access layer. But that is not possible to do with our current design. The next issue is that The book service class violates the single responsibility principle. The book service class creates an instance of its dependency, and creating an instance of a dependency is called object composition. Now, object composition itself is a separate responsibility, and the book service class should not be responsible for object composition. Rather, object composition is a responsibility of the composition root that we will discuss later. Finally, the book service instance controls the lifetime of the book repository instance. To put it differently, we can ask if the book service instance can use an existing instance of book repository. That is not possible because it's the book service instance that is creating an instance of book repository and controlling its lifetime. So in conclusion, it's clear that we should design our code to be loosely coupled. So in the next video, we will enable loose coupling by applying the dependency inversion principle. In this video, we're going to see how to enable loose coupling in our code by applying the dependency inversion principle. As we already saw, the dependency inversion principle states that high-level modules should not depend upon low-level modules, both should depend upon abstractions. So in our example, the business logic layer project, which is our high-level module, should not contain a project reference to the data access layer project, which is our low-level module. Now, if it did not contain such a reference, then it would be possible to effectively build our application starting from the business logic layer instead of starting from the data access layer. I have opened up a Visual Studio solution with a single C# class library project in it for my business logic layer. Inside the project, I have a folder called services which contains my book service class. The book service class contains a single method called addBook that takes in a title, author, and publication date. Inside the method, we want to create an instance of an entity class called book and persist it using some repository. So now I have added a new folder called entities which contains my book entity class, and the book class contains ID, title, author, and publication date properties. So back in the book service class, we can create an instance of the book entity class and assign its title, author, and publication date properties from the corresponding method arguments. Now we want to be able to persist this book entity using some repository. Now at the time of writing this business logic layer, we don't know if we are going to store this book entity in a database or an XML file or whatever. So in other words, at this time we don't know what implementation of our data access layer is going to be. So when we don't know the implementation, we need to program against an abstraction. To put it differently, we know we want to persist our book entity using a method like addBookAsync that takes in a book instance. So that's the abstraction. But we don't know how that addBookAsync method is implemented internally. So we don't know whether the method will persist the book in a relational database or an XML file. So that's the implementation. So I have added a new folder called abstractions, and this folder contains an interface called iBook repository, which in turn contains the method we talked about, that is addBookAsync, that takes in a book instance. Now our book service class needs to work with this abstraction. So in the book service class, we can create a private field of type iBook repository. Make sure to bring in the namespace, and down here call await repository.addBookAsync, passing in the book instance. Now this works fine at compile time, but it will fail at runtime because we cannot invoke a method on an interface without having an actual implementation. We will come back to this in the next section of this course where we talk about the various dependency injection design patterns that are available. Note that we have satisfied the part of the dependency inversion principle which states that our high-level module, which is the business logic layer, should depend upon an abstraction. Now it's time to implement our data access layer. I have added a new class library project to the solution for the data access layer. It contains a folder called repositories, which in turn contains the book repository class. This book repository class should contain the implementation of our data access logic. Now, according to the dependency inversion principle, our low-level module, which is the data access layer, should also depend upon an abstraction. That is, we want the book repository class to depend upon the iBook repository interface that's defined in the business logic layer. And we do this by letting the book repository class implement the iBook repository abstraction. And for that to happen, we need to add a project reference from the data access layer project to the business logic layer project. We can now implement the interface like so. Now our choice of data access implementation at this time is to persist our book entity in a relational database using Entity Framework Core. So we need to create a context class for that. So I have added a new folder called context, and inside that folder I have a class called Simple Book Catalog DB Context. This class needs to inherit from DB Context, which is part of Entity Framework Core. So we need to go to Tools, NuGet Package Manager, and Package Manager console, and set the default project to the data access project, and type install-package microsoft.entityframeworkcore.sql server, as we will be using SQL Server Express local DB. Now we can inherit from DB context, make sure to bring in the namespace, and override on configuring, and say options builder .use SQL server, and we can hardcode the connection string for now. Say server equals local db / MSSQL local db semicolon, database equals simple book catalog db semicolon, integrated security equals true, and then expose a public property of type dbSet of book called books. And now in the book repository class, inside the addBookCasing method, we can say using var context equals new simple book catalog db context, and say context.books.add book, and await context.savechanges async. Now we need to go ahead and create our database. For that we need to add a migration. So go to Tools, NuGet Package Manager, and Package Manager console, and make sure the default project is set to our data access project. Firstly, to use migrations, we need to install a set of tools. So say install-package microsoft.entityframeworkcore.tools and hit enter. Next, set the data access project as a startup project and add a migration by saying add-migration initial. We see we have our initial migration with its up and down methods. And finally say update-database. Now if we go to View SQL Server Object Explorer and then expand SQL Server, local DB, and databases, right-click the databases node and say refresh. We see our simple book catalog DB database, and if we in turn expand that and tables, we see our books table. Now that our data access layer is complete, let's go back to the book service class in the business logic layer and talk about a few things. So once again, nowhere inside the book service class we are creating an instance of book repository, so our compile time dependency to the book repository class is gone. Since the book service class is now not dependent on the book repository class anymore, we say that both classes are loosely coupled. And we enabled such loose coupling by applying the dependency inversion principle. But this completes just one half of the story. A book service object still needs a book repository object at runtime. So how do we provide an actual book repository instance for book service to work with? In other words, what about the runtime dependency between book service and book repository? That will be answered in the next section, where we discuss the various dependency injection design patterns that are available. But before that, let's have a look at volatile and stable dependencies. In this video, we're going to talk about the two types of dependencies: volatile dependencies and stable dependencies. A dependency is considered volatile if any of the following conditions are true. The dependency doesn't exist yet. The dependency is likely to change in the future. The dependency is hard to unit test. Or the dependency contains non-deterministic behavior. Otherwise, the dependency is considered to be stable. Now, it's for volatile dependencies that we should avoid instantiating them directly using the new keyword and instead program to an abstraction and use dependency injection. For stable dependencies, it's okay to instantiate them directly. For example, in the previous video, we did not create an instance of the book repository class inside our business logic layer because the book repository class is a volatile dependency. First of all, the book repository class did not exist at the time of writing our business logic layer. And second, book repository used entity framework core for its data access logic, which is likely to change if we want to switch to a different ORM. Other examples of volatile dependencies include classes included in the .NET base class library for file input-output such as FileStream, web services, and time-based services such as datetime.now because it contains non-deterministic behavior. On the other hand, in our previous example, we instantiated the book class directly using the new operator because the book class was a stable dependency. Other examples of stable dependencies include utility or helper classes and data transfer objects. In this video, we're going to talk about a dependency injection design pattern called constructor injection. In our example, we saw that the book service class does not create an instance of book repository. But a book service instance still needs to use an instance of book repository at runtime. So how do we let the book service object use a book repository object? We can do that using constructor injection. In constructor injection, we declare a public constructor that specifies one or more required dependencies as parameters to the constructor. In our case, since the book service class depends on the iBook repository abstraction, we can specify the iBook repository type as a parameter. Now, what this means is that any consumer that wants to instantiate the book service class needs to supply an instance of a class that implements iBook repository into the class's constructor. The book service class itself does not care who will do that, but as long as it receives an iBook repository object, it is okay. As we will see later, it's a component called the composition root that is responsible for providing or injecting an iBook repository implementation. Now, the passed in reference may be null, so inside the constructor, we can check for a null reference, in which case we throw an argument null exception. Otherwise, we can take the passed in reference and store it in the iBook repository field so that it can be used by other methods, such as the addBook method in our case. Now, there's a possibility that methods in this class may accidentally modify the iBook repository field, such as by setting it to null. To prevent this, we can apply the read-only modifier on our private field. In the next video, we will talk about method injection. In this video, we're going to talk about method injection. In constructor injection, we pass an instance of a dependency as an argument to the constructor and then store the passed in reference in a private field. This stored dependency will be used for all the methods in this class. Here we only have a single method, but if we had multiple methods, then the same stored dependency will be shared across all the methods. But what if we want to vary a dependency on each method call? So in one method, we may want one implementation of iBook repository, but in another method, we may want another implementation. To achieve this, we can use method injection. In method injection, we declare a parameter to a method of type iBook repository and then use the passed in reference to invoke its methods. So this means that when any consumer calls the addBook method, then that consumer needs to supply an instance of a class that implements iBook repository as a method argument. Let's revert to using constructor injection because constructor injection is a recommended approach over method injection or property injection. In the next video, we will talk about property injection. In this video, we're going to talk about property injection. To demonstrate property injection, I have added a Blazor web app project that uses static server-side rendering for the presentation layer. Note that while creating the project, I have set the interactive render mode to none. And I have set the presentation project as my startup project. This project contains an addbook.razor Blazor component. This component contains an edit form component that lets users enter book information. Now, you don't need to worry about the edit form component. That's not important for this course. Just know that the edit form component is bound to our book domain entity class, and we know the book entity class is present in the business logic layer project. So the presentation project contains a reference to the business logic layer project. The edit form component has an onValidSubmit parameter that is set to a method called submitBook. So this method will be invoked when the form is submitted with valid data. In the submitBook method, I've commented out the following lines. var service equals new book service, new book repository. So in the commented section, the Blazor component creates an object of the book service class and passes in an instance of a class that implements iBook repository to the constructor. But really, creating instances of dependencies called object composition should be the responsibility of the composition root, as we will see in the next video. So if the addbook.razor Blazor component is not responsible for book service instantiation, then it can simply use property injection to let its consumer inject an instance of a book service dependency in a property. To do that, we need to specify a razor directive at the top here @inject book service and then bring in the namespace book service. And down here, simply call await bookservice.addbook, passing in the required arguments. Now the @inject directive that we used translates to the following code. So a property called bookService of type bookService with the inject attribute applied on it. So this means that any consumer, whoever is instantiating the Blazor component, needs to assign an instance of bookService to the bookService property. And this follows that when bookService is instantiated, an object of a class that implements iBook repository also needs to be supplied to the bookService constructor. In the next video, we will talk about what we covered so far. Let's talk about what we covered so far. First, the bookService object had a runtime dependency on a book repository object. This is because bookService needed to invoke its addbook_async method. And we turned this into a compile time dependency by letting the bookService class create an object of the book repository class. This violated the dependency inversion principle and led to tight coupling. And then we applied the dependency inversion principle by letting both bookService and book repository depend on an abstraction called iBook repository. Now the bookService class no longer had a compile time dependency on the book repository class. But a bookService object still needs a book repository object at runtime. So we used constructor injection and declared a constructor parameter of type iBook repository and stored it in a private read-only field. This made the consumer of the bookService class responsible for supplying an instance of book repository into its constructor. And finally, we introduced the addbook.razor Blazor component, and instead of the component creating an instance of bookService and supplying an instance of book repository, the addbook.razor Blazor component in turn used property injection to let its consumer supply an instance of bookService into its property. Now, if we run the application in this state and navigate to /add-book, we will get a runtime exception, specifically an invalid operation exception, stating cannot provide a value for property bookService on type addbook. There is no registered service type bookService. This exception is occurring because Both the book service class and the addbook.razor Blazor component pushed the responsibility of creating instances of their dependencies to their consumers, but we are not instantiating them anywhere in our application. We will see exactly how to fix this issue in the next video, where we talk about the final dependency injection design pattern called the composition route. In this video, we're going to talk about the final dependency injection design pattern called the composition route. Composition route is a component that ties everything together. The composition route is a single place that is located as close as possible to the application's entry point method, which is main, and it is responsible for creating instances of dependencies, that is object composition. So in our presentation project, let's open the program class which contains our main entry point method. A composition route can be implemented either using pure dependency injection or using a dependency injection container. In pure DI, we create instances of dependencies manually. On the other hand, a DI container is a library that takes care of dependency injection for us. So it automates many of the tasks involved in dependency injection, such as object composition, lifetime management, and interception. These are referred to as the 3 dimensions of dependency injection. This video is focused on object composition, and we will talk more about lifetime management and interception later in this course. Going back to our code, we can use .NET's built-in dependency injection container to register various dependencies like so. Builder.services. Now, services is of type iService collection, which is part of .NET's dependency injection container, and we will talk more about it later. Then .add. Now don't worry about transient, scoped, or singleton. These are the service lifetimes, and we will talk about them later. Here, let's use the scoped lifetime and pass in as generic arguments book service, book service. This means that whenever a class or component declares book service as a dependency, then the dependency injection container will provide a book service object to the class or component. Now, whether the dependency injection container creates a new object of book service or supplies an existing one depends on the registered services lifetime, which we will see later. Since both the generic arguments specify the same type, we can shorten this code like so. Now recall that a book service object also needs an object of a class that implements iBook repository to be passed into its constructor. So we need to tell the dependency injection container about that as well. So we can say builder.services.addScoped of iBook repository, book repository. Now the book repository class is present in the data access layer, so we need to add a project reference to it and bring in the namespace as well. So this means that when book service or any class declares iBook repository as a dependency, then the dependency injection container needs to supply an instance of book repository into the class's constructor. So this way, at runtime, the dependency injection container can create and supply instances of dependencies such as book service and book repository, instead of our addbook.razor Blazor component having to instantiate book service and book repository dependencies as we saw in the commented section. So till now, we have covered the first dimension of dependency injection, which is object composition. So instead of the addbook.razor Blazor component and the book service class being responsible for object composition, we shifted the responsibility to a third party called the composition route, and we saw that a composition route is located close to the main method, and it can be implemented in 2 ways. Either using pure dependency injection, where we create instances of dependencies manually, or using a dependency injection container library, which takes care of object composition, lifetime management, and interception for us. In the next section, we will talk about the other 2 dimensions of dependency injection, which are lifetime management and interception. In this video, we're going to talk about the second dimension of dependency injection, that is lifetime management. To illustrate lifetime management, let's go back to Visual Studio, and here we have our addbook.razor Blazor component. Let's comment out the inject directive. So the component is not going to use property injection, and instead scroll down and add a public property of type book service called book service, and instantiate it directly by creating an object of book service, passing in an instance of book repository into the book services constructor. Further, let's add another razor component called child component and make it a child of our addbook component. And inside the child component, in the code block, create a public property of type book service called book service, and once again instantiate it directly by creating an object of book service, passing in an instance of book repository into the constructor. So what have we got so far? The addbook component is responsible for creating instances of its dependencies, which is object composition, and also controls their lifetime. The same is true for child component. It is also responsible for object composition and controlling the lifetime of its dependencies. Now let's revert to using property injection in the addbook component. Let's do the same for the child component. Now that both the components use property injection, inside the composition root, we can have something like the following. var service1 equals new book service, new book repository, and var service2 equals new book service, new book repository. Now at runtime, service1 can be injected into the book service property of our addbook component, while service2 can be injected into the book service property of our child component. Since service1 and service2 refer to two separate instances, each of the addbook and child components will have its own unique instance of its dependencies. Now, since the responsibility of lifetime management is shifted away from addbook component and child component and into the composition root, it becomes possible to do this. var service2 equals service1. Now at runtime, if service1 is injected into the book service property of addbook component and service2 is injected into the book service property of child component, since both service1 and service2 refer to the same instance of book service, both the components get effectively the same instance. This way, we are able to manage the lifetime of our dependencies from within the composition root. Now, we used pure dependency injection, but a DI container can also manage the lifetimes of registered dependencies. The .NET DI container supports three lifetimes: singleton, scoped, and transient. To demonstrate these lifetimes, I'll go to the addbook component and display the hash code of our book service dependency by calling getHashCode on it. And I'll do the same inside our child component as well. So if two hash codes are one and the same, then they are the same object, but if they are different, then they are different objects. Let me clarify that even if two objects have the same hash code, they aren't necessarily the same instance. But for our demo, given that we know the different service lifetimes, we can assume that that is the case. So in the next 3 videos, we'll be going to the program.cs class file and play with the different lifetime named methods such as add singleton, add scoped, and add transient, and see their behavior. In this video, we're going to talk about the singleton lifetime. In singleton lifetime, a single instance is created and reused for the entire application lifetime. Let's go to our program class and change the service registration to add singleton. And to avoid captive dependencies that we will talk about in the next section, let's also change the registration of iBook repository to add singleton as well. Now let's run the application and navigate to /add-book. We see we get the same hash code for both the parent component and the child component. This means that the same instance of book service is being injected into the parent component and the child component's book service properties. Now, this is one HTTP request. Let's make a new request by copying the URL, opening a new tab, and then paste the URL and hit enter. We get the same hash code in both the parent and child components. That is exactly the same as a previous request. So this means that for the entire application, a single instance of book service is created and reused whenever we specify a dependency of type book service, and that instance is reused across all HTTP requests as well. The singleton lifetime is ideal for objects that are expensive to create or for objects whose data must be shared across HTTP requests. In this video, we're going to talk about the scoped lifetime. In scoped lifetime, a single instance is created per scope. In ASP.NET Core, a scope maps to a single HTTP request, but we can also create a scope manually, as we will see in the next section. Back to our program class, let's change the registration to use add scoped. And if we run the application and navigate to /add-book, we see we get the same hash code in both the parent and child components. This means that the same instance of book service is being injected into the two book service properties. Now let's make a new request by copying the URL and opening a new tab and pasting the URL and hitting enter. This time we have a new hash code in both the parent and child components. This means that in our application, during the first HTTP request, a new instance of book service was created and reused for that request, and at the end of the first request, the instance was disposed. And during the second HTTP request, once again a new instance of book service was created and reused for that request, and then disposed of at the end of the request. In this video, we're going to talk about the transient lifetime. In transient lifetime, a new instance is created and used every time we need a dependency. So back to our program class, let's change the registration to use add transient and run the application. Let's navigate to /add-book. This time we see the hash codes are different. So we are getting a new instance of book service injected into the two book service properties. Let's make a new request by copying the URL, opening a new tab, and pasting the URL and hitting enter. Now we are getting a new set of hash codes that is different from the previous set. So this means that in the first HTTP request, we got two separate instances, and in the second HTTP request, we got once again two new instances. Since every time we specify a dependency, a new instance of the dependency is created and supplied, we can end up creating a lot of objects, and as a result, more work has to be done by the runtime's garbage collector. So this makes the transient lifetime less efficient. So always use the transient lifetime for lightweight, stateless services. In this video, we're going to talk about the third dimension of dependency injection, which is interception. To understand interception, let's go back to our original book service class, which created an instance of book repository in its constructor. Now in this design, it is impossible to intercept the book repository dependency. In other words, reach out to this book repository dependency and possibly modify it by wrapping another class around it and then pass it to the book service class. But in our new book service class, since it programs to an abstraction and uses the constructor injection design pattern, it makes it possible to intercept the book repository dependency by wrapping another class around it and then pass it to the book service constructor. Now, why would we need to do that? Let's say, for example, once we add a book to the database, we want to write some information to the console saying book added with its title. In our original book service class, where can we write this logic? We have two choices. We can either go to the book service class and at the end of the addBook method, we can write our logic console.writeLine book added book.title, or we can write the logic in our book repository class at the end of the addBook async method, the same logic console.writeLine book added book.title. But either way, we are violating the open-closed principle, which is one of the 5 solid principles of object-oriented design. This principle states that software entities such as classes should be open for extension but closed for modification. This means that we should be able to extend code by adding new code, not modifying existing code. On the other hand, if the book service class programmed to an abstraction and used constructor injection, then we don't have to modify either the book service class or the book repository class to add such behavior. Instead, what we can do is we can create a new class called logging book repository, and this class needs to implement the decorator pattern. So we can let it implement iBook repository and also inject iBook repository and store it in a private read-only field. In the implementation of the addBook async method, we can delegate the call to the wrapped iBook repositories addBook async method. And after this, we can write our logic console.writeLine book added book.title. This way, we are able to add our logic without having to modify existing code. Now, what this means is that when book service accepts iBook repository as a dependency, instead of passing a book repository object to the book services constructor, we are intercepting that dependency by modifying it and wrapping another class around it, which is the logging book repository class. The logging book repository class invokes the inner book repository's addBook async method and writes information to the console, and we are passing that logging book repository object to the book services constructor. In order to achieve what I said, we have to make changes to the composition root. So as you can see, I have the lines from the earlier demo commented out, and we need to register a scoped service of type book service. So say builder.services.addScoped of book service. Next, we can say builder.services.addScoped of iBook repository. We can then pass in a lambda function taking a service provider, SP. So this lambda will be executed whenever a class specifies iBook repository as a dependency. Then inside the lambda function, we can create an instance of logging book repository. Since the logging book repository constructor accepts an iBook repository implementation, we can use the passed in service provider, SP, to get a required service of book repository. Again, we'll talk more about different ways of registering services in the next section. Here we are specifying a dependency of type book repository, so we need to register that service as well. So say builder.services.addScoped of book repository. Now if we run the application and navigate to /add-book, let's enter some book information and click on the submit button. Now if we go to the console, we see our information book added with its title. This way, we are able to implement our logging behavior by intercepting the book repository dependency and wrapping a class around it called logging book repository, and we didn't have to touch the existing book service or book repository classes. In the next section, we'll be taking a more closer look at the .NET's built-in dependency injection container. In this video, we're going to talk about the basics of the .NET's built-in dependency injection container. First, let's go over some theory and then see how to implement practically in our demo. The Microsoft.extensions.dependency injection NuGet package contains all the components required for .NET's built-in DI functionality. This NuGet package references another NuGet package called Microsoft.extensions.dependency injection.abstractions, and this package contains the following types: iService collection, service descriptor, and iService provider. iService collection is a contract for a collection of service descriptors. So it is basically a type that is used for registering services. Service descriptor represents a single service registration with the DI container. So it describes a service with its service type, implementation type, and lifetime. It can also describe implementation factories and instances. And finally, iService provider represents the .NET's dependency injection container. It is used to resolve or create instances of services whenever needed. Back to the solution. I have added a console application project to the solution. And let me add the dependencies for the business logic layer and data access layer. Also, we need to install the Microsoft.extensions.dependency injection NuGet package. So go to Tools, NuGet Package Manager, and Package Manager console, and set the default project to our console application, and say install-package Microsoft.extensions.dependency injection, and hit enter. Open the program.cs class file. Let me remove the boilerplate code. I'll start by creating an instance of service collection. So say var services equals new service collection and bring in the namespace. This service collection type implements the iService collection interface that we talked about earlier. And note that since we are creating a brand new instance of service collection, this services variable does not have any services to start with. But we can use various APIs for adding services to the service collection instance. These are lifetime named generic extension methods like add singleton, add scoped, and add transient that we talked about in the earlier section of this course. So let's register our book service class and iBook repository implementations as scoped services like we did earlier. Now we will talk about the different ways of registering services in the next video, but note that these methods are just convenience methods that internally create a service descriptor instance and adds it to the service collection. For example, the call to add scoped of iBook repository, book repository is equivalent to the following code. Var service descriptor equals new service descriptor, passing in type of iBook repository, type of book repository, and service lifetime dot scoped. And finally, call the add method, passing in the service descriptor instance. To use the add method, we need to bring in the extensions namespace. So this is the equivalent code of the above method call. Let's get rid of this code. Once all the services are added, we can use build service provider to create the .NET's dependency injection container. So we can say var provider equals services.buildServiceProvider. Build service provider is an extension method on the iService collection type that when called returns an implementation of iService provider. As we can see from IntelliSense, provider is of type service provider, and if we explicitly type our variable to service provider and go to its definition, we see that service provider implements the iService provider type that we talked about earlier. So this iService provider implementation represents the .NET's built-in dependency injection container, and it can be used to resolve or create instances of services when needed. Let's go back to our Blazor web app project and comment out the lines from the previous section of this course. If we expand the project's dependencies, frameworks, and Microsoft.ASP.NET Core.app reference, we see we have the two NuGet packages installed automatically, Microsoft.extensions.dependency injection and Microsoft.extensions.dependency injection.abstractions. Now, when we call web application.createBuilder, passing in the command line arguments, this method call returns an instance of web application builder, and this builder object exposes a services property which is of type iServiceCollection. Since we are not creating a brand new instance of service collection like we did in our console application, the services property itself comes with a set of services already registered by the ASP.NET Core framework. These services are called framework provided services, and some of them are iWebHost environment, iHTTP context factory, and iLogger. Now we can append to these services by registering our book service and iBook repository services like so. Finally, when we call builder.build, that returns an instance of web application, and we can say var provider equals app.services. This services property is of type iServiceProvider, and it represents the .NET's built-in dependency injection container that contains all our previously registered services. Now, our addBook component uses property injection to inject an instance of book service. So in our web browser, when we navigate to /add-book and the addBook component will be rendered for the first time, at that point our component will be instantiated and property injection will be done. The framework internally uses the iServiceProvider implementation to get a required service of type book service. Since we already registered the book service type in our dependency injection container, the DI container can supply a new instance of that service for us. But wait, the book service class has a constructor that accepts an iBook repository as a dependency. So once again, the iServiceProvider.getRequiredService is recursively called for the constructor parameter. And since we had registered iBook repository service in our service collection, the DI container will supply an instance of book repository to the book services constructor. So this way, each requested dependency requests its own dependencies. The dependency injection container creates or resolves the dependencies in the graph and returns the fully resolved service. This entire set of dependencies that must be resolved is typically called the dependency tree, dependency graph, or object graph. In the next video, we'll talk about the different ways of registering services. In this video, we'll talk about the different ways of registering services. First, we can either use add singleton, add scoped, or add transient that accepts two generic arguments. For example, in this line, the first generic argument is the iBook repository type. This is referred to as the service type or the abstraction type. The second generic argument is the book repository type. This is referred to as the implementation type or the concrete type. So this is like telling the dependency injection container that when a class or component specifies iBook repository as a dependency, supply the class or component with an instance of book repository. Now note that the dependency injection container will resolve an instance of book repository only if the dependency is of type iBook repository. If the dependency is of type book repository, then the dependency injection container will not be able to resolve it. Alternatively, we can have both the generic arguments to be of the same implementation type. So for example, in this line, we can say book service, book service. Now this is like telling the dependency injection container that when a class or component specifies book service as a dependency, supply the class or component with an instance of book service. Now since the two generic arguments are one and the same, we can use an overload that accepts just one generic argument. We can also register services using objects and implementation factories. Let's demonstrate that. Go to our data access layer project, expand the repositories folder, and open the book repository class. Here we see that we are directly creating an instance of the simple book catalog DB context class inside the addBook async method. So the book repository class is responsible for object composition and controlling the lifetime of the simple book catalog DB context instance. Also, it is not possible to intercept our simple book catalog DB context class and possibly modify it without having to touch the book repository class. So let's use the constructor injection design pattern to inject simple book catalog DB context into the book repository's constructor. and store the instance in a private read-only field. Also, let's expand the context folder and open our simple book catalog DB context class. Here we see we are hardcoding the connection string inside the onConfiguring method. First, let's copy this connection string. Let's define a constructor for the simple book catalog DB context class that accepts a connection string as a parameter and stores it in a private read-only field. And let's pass this connection string to the useSQL Server method. Now, going back to the book repository class, we can see that we need to register the simple book catalog DB context class in the DI container. And since the simple book catalog DB context class constructor accepts a string as a parameter, and since string is a primitive type, we cannot tell the dependency injection container for every string type pass this connection string. So we need to do something about that. So let's go to our Blazor web app project and open the program.cs class file. Now note that we should always register our simple book catalog DB context class as a scoped service because it is specific to a given request and should not be shared across requests. But to demonstrate registering services using objects, let me use the singleton lifetime for now. So say builder.services.add singleton of simple book catalog DB context. Now this call as such will tell the dependency injection container to supply a new instance of simple book catalog DB context class whenever needed and use it for the lifetime of the application. But what about the connection string parameter of our simple book catalog DB context constructor? The dependency injection container does not know what to pass to it. So instead, we ourselves can create an instance of the simple book catalog DB context class, passing in the connection string to the constructor, and provide this object to the dependency injection container. So the DI container will use this object that we created ourselves whenever a class or component specifies simple book catalog DB context as a dependency. Now we can omit the generic type argument because the type is inferred. But ideally, we should register the simple book catalog DB context class as a scoped service. So what if we did this? Builder.services.add scoped of simple book catalog DB context. This does not even compile. This is because we need to register the service not by creating a new object but by providing an implementation factory. To do that, you can pass in a lambda expression that takes in an iService provider or SP, and it simply returns a new instance of simple book catalog DB context passing in the connection string. This code means that whenever a class or component specifies simple book catalog DB context as a dependency, the dependency injection container will invoke the passed in lambda expression, and whatever object the lambda expression returns, that will be used to resolve the simple book catalog DB context dependency. Once again, we can omit the generic type argument because the type is inferred. Finally, let's discuss how to register open generics or types that take a generic type parameter. Let's say we have an interface called iRepository of T and a class that implements the interface called repository of T. Now how do we register this? For instance, if we are using the scoped lifetime, we can use an overload of the addScoped method that takes in two parameters of type. So we can say builder.services.addScoped passing in type of iRepository of, type of repository of. In the next video, we will talk about registering groups of services with extension methods. In this video, we're going to see how to register groups of services with extension methods. In our example here, we have a group of related services. We can put this group in a single addGroupName extension method, and inside that method, we can register both these services. So let's do just that. Right-click our Blazor web application project and select Add New Folder. Name the folder Extensions. Right-click the Extensions folder and select Add Class and name the class Simple Book Catalog Service Collection Extensions and click Add. Now, extension methods should live in a public static class. So let's turn this into a static class, and then inside the class, create a public static method that returns an iService collection, and we can name the method, say, add application services. Now we are creating an extension method on the iService collection type. So we need to use the this modifier and then specify our type, which is iService collection, and let's call the parameter services. Inside this method, we need to register both the services. So let's go to our program class, cut these lines and paste them here. We can now modify these lines to use the services parameter instead of builder.services. And finally, to allow chaining, we can use the return statement and return services. Now back to the program class, we can call our extension method like so: builder.services.addApplicationServices, and make sure to bring in the namespace. Now Microsoft itself uses this convention to register a group of related services required by a framework feature. For example, if we want to use a framework feature such as support for server-side rendering of Razor components, we don't have to individually register services. Instead, we can use the add Razor components extension method provided by the ASP.NET Core framework, and that method takes care of all of those registrations for us. Finally, let's talk about one more extension method provided by the framework, the addDBContext method. Now let's go to our simple book catalog DBContext class in our data access project, and let's talk about an issue here. We have used the useSQLServer method inside the onConfiguring method. This means that we have configured our data access project to use the SQL Server database provider, and that configuration is present right inside our simple book catalog DBContext class itself. So with this design, it's not possible to configure our data access project to use a different database provider from outside this class, like in the composition root. So how can we improve this? First, let me modify this code and then explain what it does. First, let's get rid of the onConfiguring method, and instead of using a connection string as a parameter to the constructor, let's inject a DBContext options of simple book catalog DBContext and call it options, and pass this to the base class constructor as well. Now let's go back to the program class, and instead of the simple book catalog DBContext service registration here, we can use the addDBContext extension method. But first, let's copy this connection string and get rid of these lines. Now we can call builder.services.addDBContext of simple book catalog DBContext. Now this method internally registers the simple book catalog DBContext class as a scoped service, and it registers a few others as well. And as a parameter to the method, we can pass in a lambda expression that takes in an options builder. We can create a block and say options.useSQLServer, and let's paste in the connection string that we copied earlier. Now let's understand how this works. The book repository class accepts a simple book catalog DBContext as a constructor parameter. At runtime, when the book repository class is instantiated, an instance of simple book catalog DBContext needs to be passed to its constructor. As I said earlier, the addDBContext of simple book catalog DBContext registers it as a scoped service, so this is fine. But our context class itself accepts a DBContext options as a constructor parameter. So how will an instance of DBContext options be passed to our context class? Well, the addDBContext extension method internally invokes the lambda function passed to it whenever an instance of DBContext options is needed. So this will create a DBContext options builder object, and finally the options property is invoked on it, which will then return an instance of DBContext options that is then passed to our context class constructor. So this way, the addDBContext extension method lets us configure both the database provider and connection string from within the composition root itself, rather than putting it directly in our context class. In the next video, we're going to talk about registering multiple implementations of the same service type. In this video, we're going to talk about registering multiple implementations of the same service type. Inside the data access project, in the repositories folder, I have added a new class called Dapperbook repository that implements the iBook repository abstraction and injects simple book catalog DB context into its constructor as well, and it stores it in a private read-only field. The addBookCasing method simply throws a not implemented exception. Now let's go to our simple book catalog service collection extensions class in our Blazor web app project and add a call to services.addScoped of iBook repository, Dapperbook repository. Now what we have done is we have registered multiple implementations of the same service type or abstraction type. Now let's go to the book service class in our business logic layer and add a breakpoint right here. Now let's run our application and navigate to /add-book. And if we hover over the repository parameter, we see that it's of type Dapperbook repository. This means that if we register multiple implementations of an interface and specify the interface type as a dependency, then we get the last registered implementation. However, this doesn't mean that the book repository implementation is being replaced by the Dapperbook repository implementation. Both the implementations are still registered. We can prove this by going to our book service class and changing the constructor parameter to IEnumerable of iBook repository and call it repositories. And let's comment out the constructor code for now and run the application and navigate to /add-book. We see the repositories argument contains two elements, and if we expand this, we see it contains both book repository and Dapperbook repository. This means that both the services were registered in the DI container. Now let's uncomment our code and change our constructor parameter back to iBook repository. Going back to our simple book catalog service collection extensions class, what if we want to register our Dapperbook repository implementation only if a previous implementation such as book repository has not already been registered? For that, we can use the try_add_scoped method. We need to bring in the extensions namespace. Now if we run the application and navigate to /add-book and we hit the breakpoint, the repository variable is of type book repository, not Dapperbook repository, because the Dapperbook repository implementation was not registered because a previous implementation, which is book repository, was already registered. Now, what if we want to replace our first registration of iBook repository, which is book repository, with a new registration such as Dapperbook repository? For this, we can use the replace method. This method is not generic, and instead, we need to pass in a service descriptor object as an argument. So we can say new service descriptor, passing in type of iBook repository, type of Dapperbook repository, and service lifetime.scoped. Now if we run the application and navigate to /add-book, this time we see the repository parameter is of type Dapperbook repository because it replaced the previous book repository registration. Let's remove this and add our scoped registration for Dapperbook repository back. What if we want to remove all registrations of a given service type? To do that, we can say services.removeAll of iBook repository. If we run the application now, we will get an exception because book service accepts iBook repository, but we have removed all iBook repository registrations. Let's get rid of the remove all method. Now we will talk about keyed services. Keyed services were introduced in .NET 8 and they basically let us register multiple services of the same service type, each with a different key, and then use a particular key for the lookup. So let's change the registration to use addKeyedScoped. This method accepts an object as a parameter, so you can pass in any object as long as it correctly implements the equals method. For this demo, we can use a string say EF core. Likewise, turn the second registration to add keyed scoped as well, and pass in a string as a key, say Dapper. Now in the book service class constructor that takes an iBook repository as a dependency, we need to add the from keyed services attribute, and this attribute is present in the Microsoft.extensions.dependency injection.abstractions NuGet package. Since our business logic project does not reference this package, let's add a reference to it by going to Tools, NuGet Package Manager Console, set the default project to our business logic project, and type install-package Microsoft.extensions.dependency injection.abstractions and hit enter. Now to our constructor parameter, we can apply the from keyed services attribute, bring in the namespace, and to this attribute we need to pass in a key. Since we registered book repository using the key EF core and Dapper book repository using the key Dapper, if we want to inject an instance of book repository into this constructor, we need to specify the key EF core. Now if we run the application and navigate to /add-book, we can confirm that the repository parameter is of type book repository. Let's remove the from keyed services attribute and change our service registration back to using add scoped. In the next video, we will take a look at captive dependencies. In this video, we're going to talk about captive dependencies. Captive dependencies refer to a situation where a long-lived service, example a singleton, depends upon a short-lived service, example scoped. This is a misconfiguration of service lifetimes. If a singleton captures a scoped service, it could end up using a disposed instance or sharing it across requests, which breaks the expected behavior, leading to bugs. Back to our solution. In the Simple Book Catalog Service Collection Extensions class, I have commented out the service registration for Dapper book repository because we no longer need that. And I have used add singleton for the book service registration. But the iBook repository implementation is still registered using the scoped lifetime, so it is expected to live only within the context of a single request. However, since book service is a singleton and depends on an iBook repository implementation, it captures that dependency when it is constructed. As a result, the iBook repository instance ends up living for as long as the book service instance, effectively extending its lifetime beyond the intended scope. So we say the book repository dependency is a captive dependency. In the next video, we will see how to create scopes manually. In this video, we're going to see how we can create a scope manually. Let's go to our Blazor web app project and open the program.cs class file and copy the call to add DB context. Now go to our console application project and open the program class and paste the code right here and change builder.services to just services and bring in the namespace Microsoft.entityFramework core. Set the console application project as a startup project. Here we are calling services.buildServiceProvider. This is going to create what is known as the root service provider or the root dependency injection container. Now, let's use the getRequiredService method on the iService provider to get a required service of type bookService. So say var bookService1 equals provider.getRequiredService of bookService. And then let's say console.writeLine bookservice1.getHashCode. Similarly, let's resolve another instance of bookservice and also print its hash code to the console. Finally, let's go to debug and click delete all breakpoints because we added a breakpoint earlier. And then let's run our application. We see we get the same hash code. This is because we are getting the same instance of book service. So what's happening? First, we registered our book service class as a scoped service. Then we called services.buildServiceProvider that created a root dependency injection container. But after that, we are calling getRequiredService method directly on our iService provider without creating any scope. In the section Lifetime Management and Interception, we saw that in ASP.NET Core, a scope maps to a request. So in a given HTTP request, a scope is automatically created and we can resolve scoped services in the desired manner. But what about console applications? Maybe we want to process items one by one from a queue. In this case, a scope is not automatically created. So if we try to resolve a scoped service from the root dependency injection container without creating a scope, the service behaves like a singleton. So we have to create a scope manually. In other words, we have to create a custom scope. So how to do that? First, let's comment out these lines of code. We need to create what is known as an iService scope implementation. We can do that by calling the createScope method on our provider instance. Since iService scope implements iDisposable, we need to wrap it in a using statement. So say using var scope equals provider.createScope, and within that scope, we have access to the underlying dependency injection container via the service provider property. So say var bookservice1 equals scope.serviceprovider.getRequiredService of bookservice, and let's print the hash code of the bookservice instance to the console. Now copy these lines and paste them down here and change this one to bookservice2 and do the same thing here. Now let's create a second scope by copying this entire using statement and pasting it down below. And if we run the application, we see we get one unique instance for each scope. So what's going on? First, we registered our bookservice class as a scoped service. Then we called buildServiceProvider that creates our root dependency injection container. Then we created a scope inside of it, and from within that scope, we called serviceprovider.getRequiredService of bookservice. This will resolve a new instance of bookservice, and within that same scope, when we called getRequiredService the second time, the previous instance of bookservice was used. When we created a second scope and we called getRequiredService on the service provider, it resolved a new instance of bookservice, and that same instance was used the next time we called getRequiredService within that same scope. Finally, a quick word about the difference between getRequiredService and getService. GetRequiredService and getService are two extension methods on the iService provider interface. The getRequiredService method returns a service of type service type from the dependency injection container. If there is no registered service of type service type, then it throws an invalid operation exception. The getService method, on the other hand, also returns a service of type service type from the dependency injection container. But if there is no registered service, then it does not throw an exception. It simply returns null. In the next video, we will take a look at scope validation. In this video, we're going to talk about scope validation. Let's go to our console application project and open the program.cs class file. Now let me change our book service registration to add singleton instead of add scoped. And since book service depends upon an iBook repository implementation, and we have registered book repository as a scoped service, the book service instance, which is a singleton, will capture its book repository dependency. So the book repository dependency is now called a captive dependency. As we saw earlier, this is a misconfiguration of service lifetimes. But if we run the application, we get no runtime exception. Let's change our book service registration back to using add scoped, and let's uncomment these lines where we are retrieving a scoped service directly from the root dependency injection container instead of creating a scope manually. Uncomment these lines where we are creating a scope as we should. Once again, if we run the application, we get no exception. This means that by default, scope validation is not being done. To enable scope validation, when we call buildServiceProvider, we can pass in validate scopes set to true. Now if we run the application, we see we get an invalid operation exception, cannot resolve scoped service from root provider. So we can confirm that scope validation is being done. Similarly, uncomment these lines, uncomment the lines where we are retrieving the service directly from the root dependency injection container, and change our book service registration back to add singleton. So now we have a captive dependency, and let's run the application. Once again, we get an invalid operation exception stating cannot consume scoped service from singleton. This is because scope validation is being done. So when scope validation is turned on, the service provider makes sure that scoped services aren't resolved from the root dependency injection container and scoped services are not injected into singletons. Let's change our registration back to using add scoped. Now in ASP.NET Core 2.0, scope validation is turned on by default in the development environment. So let's set our Blazor web app project as a startup project and expand the properties folder and go to the launchsettings.json file. We see the environment is set to development. Now if we open our simple book catalog service collection extensions class and change our book service registration to use add singleton instead of add scoped and run our application, we get an exception because we cannot consume a scoped service from a singleton. Let's change our registration back to add scoped. In the next video, we're going to talk about disposable dependencies. In this video, we're going to talk about disposable dependencies. In .NET, the built-in dependency injection container is responsible for managing the lifetimes and disposal of objects it creates, particularly those that implement iDisposable. So when a type implements iDisposable, the dependency injection container will automatically call the dispose method on it at the appropriate time, depending on its registered lifetime. Back to our solution, let's right-click our Blazor web app project and select Add Class and name the class disposable type and click Add. Let's assume that this type refers to some unmanaged resource. So this type needs to implement the iDisposable interface, which contains the dispose method. And within the implementation of the dispose method, we're just going to write some information to the console, say disposable type getting disposed. Now let's use property injection to inject this disposable type into our addBook component. And finally, go to our simple book catalog service collection extensions class and register our disposable type as a scoped service. Now let's run our application and navigate to the addBook component by going to /add-book. Remember, this is one scope because it is one HTTP request. Let's create two more scopes by opening two additional tabs. Now if we go to the console, we see our disposable type getting disposed message 3 times. This is because the dependency injection container created a new instance of disposable type for each scope or request, and at the end of each scope, the DI container automatically invoked the dispose method on each disposable type instance. Now let's change our disposable type registration to add singleton and run our application and navigate to the addBook component. And let's create two new scopes by opening two additional tabs. And if we go back to the console, we don't see our message. This is because the disposable type is registered as a singleton, and singletons live for the lifetime of the application, and it's only when the application shuts down, the dependency injection container will invoke its dispose method. Now note that if you register a service using an object directly, like for example, services.addSingleton and passing in new disposable type, then the DI container does not invoke the dispose method on the disposable type instance automatically. We are responsible for disposing of it. Hi everyone, and thanks for taking my course, Dependency Injection, a C# Developer's Guide to DI Patterns. In this course, we learned what dependency injection is and how it works, And we talked about the 3 dimensions of dependency injection, which are object composition, lifetime management, and interception. Finally, we had a look at some of the features of the .NET's built-in dependency injection container. So I hope you found the course informative and helpful, and thank you once again.